Hi everyone, and welcome to this YouTube series on the Construction Studies foundation details. In this series I'll be breaking down each foundation type step by step, helping you to understand how they're constructed and most importantly how to draw them accurately for your exams. Some students find details a little challenging, so the purpose of this series is to simplify the drawing process using animated PowerPoints to show exactly how each foundation is built up layer by layer and go through some key details that you can use in your exams. Hopefully by the end you'll have a clear understanding on the variety of foundations. By the end of this video you should be able to describe and draw a strip foundation showing all key components clearly and accurately to a scale of 1:10. You should also be able to identify the main parts of the strip foundation, explain when and why a strip foundation may be used, an advantage and disadvantage, produce an accurate 1:10 drawing showing all key construction details. To give an overview, a strip foundation is one of the most common foundation types used in domestic construction. It consists of a continuous strip of concrete that supports load-bearing walls. An advantage of a strip foundation is it's simple and cost-effective to construct, making it ideal for most low-rise buildings on stable ground. A disadvantage is it's not suitable for weak or variable soil conditions as it relies on good ground-bearing capacity. Strip foundations are usually used for buildings with light loads on firm, even ground like standard houses or small extensions. The first thing I like to do is I start off with the foundation, and this foundation is going to be 350 millimeters up and then 1050 millimeters across, but because this whole drawing is a scale of 1:10, it's going to be 35 millimeters up and 105 millimeters across. We can see that this foundation is reinforced with steel, evident by this dark line here and these 4 circles. We can also tell that it's a concrete foundation, evident by these small little triangles as well. And in your exam, you will also need to state that this is a reinforced concrete foundation, and you can do so just by showing these triangles and just by showing this steel rod here with these 4 circles. On top of the foundation, we are going to start constructing our 350 cavity construction. Each of these blocks here are 200 millimeters in height, and you can see the width of this wall here is equal to the depth of the foundation here. The foundation is 3 times the width of the 350 cavity wall here. In between this, we are going to have our concrete infill with our small little slant, and you can tell again that this is concrete, evident by the triangles. The next thing, we're going to head on over to the left and we're going to draw in the ground. So this is the ground on the outside of the wall. The total distance between this line and this line is 600 millimeters. So all I've done is I've gone up 30. I've got my 60-degree set square, just went up at 60 degrees, and I went out just a non-specific distance, I'd say about 50 millimeters, up 30 again, and then just brought it straight across to meet the cavity wall here. Then to show that it's just an outside ground, I just drew in a few lines here, and these are just 45-degree lines. You don't need to fill in the whole box, just fill in a couple there on the side. Going over to the right side, I did the same thing again, and this is going to be where we put in our hard core. So the same again, went up at 60 degrees, totaling 300 millimeters, went across about 150 millimeters, and then up again 30 millimeters, and then just brought it across again until it met the cavity construction. The distance between this and this is 150, and the distance between here is 150 as well. Now again, just keep in mind we're doing this from a scale of 1:10, so that 150 is actually going to be 15 and 15. Following on from that, what I like to do is I like to go up 1, 2, 3, 4, 5 concrete blocks in total. So that will end up being 1000 millimeters or 100 millimeters from a scale of 1:10. And this is going to end up being 100 millimeters or 10, then 50 cavity, 100 insulation, and then a 50 internal leaf. So this is our external leaf here, our cavity, our insulation, and our internal leaf here. And all I've done here is I've gotten my 45-degree set square and I've just drawn a few lines up just like that, and then I just coloured it in green. The next thing we're going to do, we're going to pop on back over to the right hand side and we're going to draw up 40 millimeters or in this case 4, then bring it straight across here, and this is going to be our sand blinding. And we can tell that it is our sand blinding just by the few dots here dotted in and around. And you can mark that in your basically in your exam by dotting your pencil. With the hardcore as well, just draw in a few little rocks, just like this, circular rocks, just to show that it's hardcore as well. On the left side here, we have got our 30 installation here, again marked off with our 45-degree set square and just coloured in green. On top of this then, we have also got then our insulation, and this insulation then is a total of 100 millimeters. So again, just 10, and then just crossing it off with your 45-degree set square and colouring it in green. Then secondly, we have got our concrete subfloor, and this is a total of 150 millimeters or 15 millimeters. And we can tell it's concrete, again, evident by our triangles. On top of our concrete subfloor, we have got our 25 millimeter flooring. And this is the flooring that you would be walking on inside the household. So, on the internal leaf, just on the inside here, we have got our 12 millimeter render. And then on the outside here then, we have got our 18 millimeter render then as well. Once we have that done then, we are going to put in our damp-proof membrane here, or also called our radon barrier. And the radon barrier is essentially a barrier that prevents radon gases that generate within the foundation, and it stops it from transferring up into the dwelling. It acts as a barrier. We're also going to put in our DPC, which is our damp-proof course, and the damp-proof course stops any moisture from travelling up the foundation or from block to block, and it stops it here, and that process is known as capillary action. Capillary action is the process in which water travels up through the blocks, and this stops damp and rot preventing or occurring. Here we have also got our wall ties as well, and I've just put in 2 wall ties, and they just connect the external leaf and the internal leaf together, securing it. Once you have done all of that, we can start labeling in our features for the strip foundation. So here we've got our external render, external leaf, our cavity, insulation, and then internal leaf. And here we've got our wall tie and our DPC, or our damp-proof course. Then we're followed on with our 30 insulation, 25 flooring, concrete subfloor, our insulation, our radon barrier, which is 1200, and our 40 blinding. And then lastly, just down here, we've got our hardcore, our concrete infill just over here, 150 millimeters. And then we have got our 1050 by 350 reinforced concrete foundation. Once you have that drawing, this is how it should look on your page. So this is the drawing that I've after doing, and this is the strip foundation that I've done. Over on the right hand side here, I've got my keywords, so evidence of new learning, and I've labelled in everything then as well. Alright, let's do a recap before we finish up. Our learning intention was to describe and draw a strip foundation. Our success criteria were to identify its key parts, explain when it's used, and draw it accurately to scale, identify an advantage and a disadvantage. We also learned that a strip foundation is simple and cost effective, but it's not ideal for weak ground conditions. Thank you very much for watching this video, and I will see you in the next one. Take care, bye bye.